Hello, everyone. Welcome once again to our series on strength of materials and to this channel, Making Life Easier. Kindly subscribe, like, share, leave your comments and suggestions as well. In this video, we are looking at axial deformation of statically indeterminate composite bars. Statically indeterminate composite bars. So let's look at our question and how to solve it. Good. The stainless steel post A has a diameter of B equals to 3 inches and is surrounded by red brass 2B. Both rest on the rigid surface. If a force of 15 kips is applied to the rigid curve, determine the average normal stress developed in the post and the tube if EST is equal to 30 KSI and EBR is equal to 15 KSI. Let's look at how to solve this problem. And this is the diagram. So quickly, let's look at how to solve this problem. This is our question which we are given. And we have been asked to determine the forces in each of the structures above. So in the question, as we see from the previous page, we have been asked to determine the forces in each of the bars. When we get a question like this, as you can see on the screen, it is a composite bar, composite in shape. So we have a composite bar. And when we have a composite bar like that, what is happening is that we have two bars. So we have the yellow bar and then we have the red one, which is here. And we have been asked to determine the forces. Because it is a composite bar, it means that this force which is applied here is distributed in both bar A, and in bar B. So quickly, let's look at how to solve this problem. This composite bar is solved by first drawing the free body diagram. And once you have been able to draw the free body diagram, you can be able to write your equilibrium equations. So let's draw the free body diagram for the whole structure. Our free body diagram is going to look like this. So we have a force of 15 kips applied at this side. This is 15. 15 kips applied. And because we have two tubes, they are all going to exert a force which is opposite to the force applied. Therefore, we can say that the steel is going to have this F steel, we can call it F steel. And in the same way, the brass, the red brass, is also going to exert a force which is opposite to the applied force. So we can call this F brass. So from there, we can write our equilibrium equation. We know that any force moving upward is positive and any force coming downwards is negative. So from there, we can say that 15 coming down is negative. So minus 15 plus our F still is going up. So it's going to be positive. And our F brass is also, the brass material is also, the force is moving upwards and it's going to be positive. will be equal to 0. And from there, we can say that the F steel plus the F gas should be equal to 15. To be equal to 15. And once we have been able to do that, because we have a composite bar, we know that the deformation in the portion A should be equal to the deformation in the portion B. That is going to be our assumption. So the deformation in A should be equal to the deformation in B. So we can say that the deformation in the steel material should be equal to the deformation in the brass. And once you have been able to write that equation, we can write the deformation equation for both the steel and the brass. And we know that the deformation equation, you are going to get the P, the force in the steel, plus the length of the steel over the area of the steel times the modulus of elasticity for steel to be equal to the force in the brass material plus the length of the brass material and the length of the brass material over the area of the brass and the modulus of elasticity of the brass. And once you are able to do that, we know the length of the steel is the same as the length of the brass, but we have different diameters. So for the steel, we were told that the diameter of the steel. Sorry for that. We know that the diameter of the steel is this steel. From the question, we know that the diameter is 3 inches. But let's look at the diameter of the brass material. The diameter of the brass, from the question, we are told that if I clean everything which is there, you will see that we are told that the radius from the center to the end of the brass material is 4 inches. The radius is 4 inches. So it means that the diameter of the whole structure there should be equal to 8 inches. And we are told that the diameter of the yellow portion, which is for the steel, is 4. It's 3. And we also know that the distance of that insulation between the two metals, we are told that it is 0.5 inch. Therefore, if you want to get the thickness of the brass material, it should be the minus. If you want to get the thickness of the brass material, it's going to be the thickness of the steel minus the thickness of the insulation medium between the two surfaces. So it means that we can see that the diameter of the brass should be equal to the diameter of the steel sorry for that. It should be equal to the diameter of the whole structure. The diameter of the whole thing, which we have indicated here that it is D. It is D minus the diameter of the steel minus the diameter of the insulation. It is 0. The thickness is 0.5. But here, 0.5 and 0.5. If you are looking at the diameter, then the radius of this is 0.5. So this is also going to be 0.5. So which we are going to get the diameter of the insulation medium. So from there, we can say that the diameter of the brass should be equal to the total diameter minus the diameter of the steel, which we are told that it is the diameter of the steel, which we are told that it is 3 inches, plus the diameter of the insulation medium. So the insulation is from this point to that point. It's from this point to that point. Okay, so we have the 0 point. Sorry for yes, minus the diameter of that of the insulation. So let's see from the question. And we are told that this, what we have here is, sorry for that, is 0.5. So if this thickness is 0.5 and that is 0.5, the whole thing is going to be 1 inch. 1 inch. So from there we can see that the diameter of the brass should be equal to 8 minus 4. 8 minus 4. Good. And we can just put them into our equation, and from there we can be able to evaluate the value of the forces in each of them. So we can say that P steel, so putting the values into this formula, we don't know P steel, so we can just put P steel there. L steel, we know the length is 6 inches, so times 6 over the area of that side. So the area will be 3.142. The area will be equal to 3.142 sorry for that. The area will be equal to 3.142 times the diameter square, which is in this case 3 square over 4 times the modulus of elasticity. And the modulus of elasticity is modulus of elasticity from this one, we are giving it as 30 times 10 to the power 3. To be equal to the deformation in the brass, which we can say that is P brass times the length. The length is also 6 over 3.142 times the diameter, which we have been told that it is 8 minus 4. Square. So 8 square, the diameter of this square minus this square, all on 4 times our modulus of elasticity for that side, which is 15, which is 15 times 10 to the power 3. And from there, we can just simplify this and simplify that. And what do we get when we do that simplification? Yes, so from the simplification, we are going to get, when we simplify that, we are going to get 2.8, 2.829 times 10 to the power negative 5 PST is equal to 1.0, sorry for that, 1.061 times 10 to the power negative 5 dr. So this will be our equation 2. And what we have here is our equation 1. Therefore, we solve 1 and 2 simultaneously. And from there, we'll get the value for, don't forget that the force, the FST here is the same as this PBR. So you can also substitute that there. It's the same as the force Fx is the same as PST. So we can substitute that here. And the force FB is the same as this FBR. So we solve this second equation and this first equation simultaneously. And from there, the value for Fx, which is the same as PST, will be equal to 4.18 No, it's just 4.1. Sorry for that. The value should be 4.1 kips. 4.1 kips. And the value for FB should also be equal to 10.9 kips. 10.9 kips. And we are done solving the problem. That was pretty much very simple. And we hope you have understood the concept. And if there's anything you don't understand, you can also let us know at the comment section. Once again, we want to thank you very much for your time and for staying in touch with us up to this point. We appreciate your effort. If there is anything you don't understand in this question, kindly let us know at the comment section. Once again, thank you for watching. Kindly share, like, subscribe, and hit the notification bell as well. Have a good day. See you in our next video. Until then, bye-bye.